I just want to show you something about acetic acid. It's going to become very important in this chapter. It's one of the more important chemicals that we use here. Acetic acid, CH2, that's a way of writing it. This is the acetate, right, ion, correct? Acetate, yes, you get it? So let me show you though, in terms of organic chemistry, it's the active ingredient in vinegar. That's acetic acid, okay? And I put a C here, double bond O, O, and then H. That's acetic acid, and what happens is this. This is pretty nonpolar. There's a lot of nonpolar, polar, there's a lot of stuff going on here, okay? This is the H from right here. That's the H from right there. You can call this ethanoic acid, okay? Okay, we don't really do a lot of organic chemistry in here. You'll do that in IB next year. Ethanoic, it comes from ethane, 2 carbons, ethane, ethene, ethyne, etc. Oic comes from, this group is called a carboxyl group. It's the organic acid group, COOH, okay, in the last problem. It's called a functional group, clear? What happens is this is some of the organic chemistry. This is some of the mechanisms involved. This is a double bond O. My organic chemistry teacher kind of explained it like this, and I'll never forget it. This was like, God, 40 years ago. She said that this particular structure acts kind of like an electron vacuum. It kind of sucks electron charge into it. Clear? So it kind of weakens this bond as a result. The electrons kind of get pushed this way. So the charge that's holding that H in place is not as strong as it could be. Clear? So for instance, this hydrogen is not as affected by it, but this whole oxygen thing going this way, it acts kind of like a vacuum cleaner. So that kind of weakens that bond. So that is allowed to come off. So acetic acid is an acid, but you can drink it. I mean, you don't want to drink glacial pure acetic acid, but vinegar is fine. The dissociation constant is quite small, so it doesn't dissociate that much. The Ka, I'll never forget this because this is how much, I remember this from 40 some years ago. It's 1.8 times 10 to the negative 5. It's one of the few things. Of course, I still remember my student number from college. A little weird. What was it? 433196. Never forget it. So the Ka is very small, so it's not that strong of an acid. But the whole reason it becomes an acid, Neve and Egan, is because you're tutoring him. I understand completely. It doesn't surprise me. So the H becomes, so that is actually makes it an acid. Clear? So this carboxyl group kind of has these electrons going this way. Okay, these are not weakened really. You know, it's kind of like, it's kind of like, a hydrogen's going to come off. This is the one that comes off, not these. These might be weakened a little bit. I don't know. I'd have to look at some data, but that's the one that gets weakened because of this flow along the oxygens. Clear? Okay. The book really doesn't call it acetic acid. That's a common name. The actual IUPAC organic name is ethanoic acid. Clear? We're done. Now,